Hi, I'm Finley, and today we're making sulphuric acid from copper sulphate pentahydrate. Here I've prepared a solution, or had prepared a solution, of 30 grams copper sulphate and 174 grams of water. I used the fairly simple process of electrolysis using this old car battery charger that uses a transformer to turn the mains voltage into a lower, more standard voltage, and then turns the AC to DC current. And I use that current to split the copper from sulphuric acid, leaving the sulphuric acid in a kind of brine solution left over after filtering. So previously I had electrolyzed this solution to leave me with a small mass of copper and some more concentrated sulphuric acid left in solution. I'm using these old batteries that have graphite rods inside. I'm using them as the electrodes, and I'm using this copper wire as the cathode. So this will be plated with copper as copper is deposited. I've covered the top of this in petroleum to stop it from plating because of the setup of this conical flask. And from previous attempts you can see that this graphite rod has kind of lost its shape. Yeah, but we've done it before, and because of the nature of the graphite rod, it powders and loses its structure. So I've had to filter it once to get rid of a lot of the graphite powder, and as you can see that causes a lot of mess. But the setup here, I'm actually using a Tesla coil because I can. I'm using that as the heatsink, and the fan here that's connected up in series to our power supply to provide additional cooling, because this process can get quite hot with too much voltage. But having the fan wired into this circuit, it also takes down some of the voltage, so that makes it a lot easier. But yeah, the higher temperatures don't favour the reaction because it leads to the destruction of the graphite rod and makes everything a bit less efficient. We have now set up the copper and graphite electrodes. I'm using yet another transformer here just to keep this clip balanced so that the graphite rod doesn't fall over. It's very precariously balanced, but it works. And then the petroleum on the copper wire prevents electrons moving directly between that gap there, which is a lot shorter and can cause heating and loss of product and overall just inefficiencies. So hopefully it should plate down here where the distance is larger. Again, these fans and heat sinks help to cool everything down, and a thermometer here if I need to measure the temperature. This power supply, when turned on, you can see the fan is keeping everything cool, and if we get closer here, then you can see both electrodes are bubbling. This copper wire will be being plated with copper, and the graphite will just be slowly dissolving into solution, which isn't what we want, but kind of unavoidable here. When this is all over, we should have a theoretical molar mass of about 1 m of sulphuric acid and overall about 11 grams of copper. I will set this up on a time lapse so you can see it unfold. So we let the solution electrolyze for the duration of the time lapse, and we've left it overnight to let all of the graphite powder kind of settle to the bottom. And as you can hopefully see, it is very clear, and we can tell that there aren't any copper ions left in solution because it's lost its characteristic blue colour, and it is now fairly clear and transparent. But next steps are to take all of the electrodes out of the solution. As you can see, hopefully, the petroleum's kind of stopped the electroplating on the on the copper electrode. Only has it plated at the bottom, and there's not really much left of our graphite. But yeah, we will tidy this up now. So here we are, the graphite electrode, not much left of it. It's pretty done for, and everything's coated in a messy layer of graphite powder, so I recommend doing this in a place that's probably more suitable than this. But as you can see, the petroleum, I think, has done its job, and there isn't actually as much copper plated onto the wire as much as I thought. But I imagine that's because the graphite powder actually in the solution is acting as a mobile cathode. So because it's conductive, it can conduct the same as the copper wire here, and they've actually, I reckon the graphite powder's actually been coated in a layer of copper in solution. So I think what we'll find is that a lot of the copper is actually still in the solution and not been plated onto the rod, but nevertheless it is still not as ions in the solution now, which is what we want. So we'll filter it off and see what we have left. Now here's the solution by itself, and first things first, we're actually just going to decant it into this beaker instead, because when filtering, the funnel fits much nicer in the conical flask than the beaker, and this should hopefully fit. It's a lot easier to pour out of the beaker as well because of the little spouts on the end, but we want to make sure that we are getting everything out of here because we don't want to lose any. And at the end we'll calculate a percentage yield as well. So I'm going to clean off this flask. We are just going to use a bit of water to properly wash this out and get all of the acid and graphite out of the conical flask, because we're ultimately just going to boil off the water anyway, so that should be okay. And then once we have done this, we are going to filter everything out. So we can put that to the side and sort that later. Now this is all of our acid. So let's clean out the conical flask and set up a filtering station. We are now all set up for filtering. Unfortunately, I'm just having to use paper roll here because I haven't invested in proper filter paper yet. But this, if all goes well, it should have the same effect. And remove the book away so that you can see it better. Actually, no, it works with the book. I'll move the camera higher up. There we go, that's better. Now, hopefully, if we filter off this solution, we should get a nice, clear, roughly 1 molar solution of the acid coming through. I am going to put this rod here so that it trickles down the rod instead of the body of the beaker, but it should all be the same. Well, it looks good so far. I don't really see any visible impurities. Obviously there will be very small ones, but it's okay, we can deal with that. I will make another time lapse of this filtering through. It's still trickling through, but you can see it is mainly pretty clear. You can't really see too many particulates, and it has a slight bluish tint, but that's as good as you're going to get it really, and it's not really noticeable from above. It's only at this angle. It might even be the glass, but we'll let that go through properly and then see what we can do with this. Finally, to evaporate off all of the water and make the sulphuric acid a bit more concentrated, we're going to use a lava lamp. I've never seen anyone do this before, but by placing this wire mesh on top of the lava lamp bulb, this actually gets to very high temperatures, and especially with the metal on top, can evaporate off the water fairly effectively. And you want to do it slow because you don't want any of the sulphuric acid molecules to evaporate as well, because that would be bad and would affect our yield. So we'll leave this on for quite a while. We'll put a thermometer in it as well to make sure that it doesn't go too hot. It should stay around 60 degrees Celsius and slowly let the water escape as vapor and increase our concentration. This is the final setup, and we have added some aluminium foil around it as well to make sure, well, I don't know, just to help with thermal insulation. But we'll let it heat up. It's only around 20 degrees Celsius. I've just turned it on, but it is on, and yeah, it is on, and we will check back on it in a while. After around a week of heating, the solution has finally reached around 20 or so milliliters of sulphuric acid. This should be roughly around 5 molar, 35% concentration. And we can now turn this off and put this to the side. This concentration is enough to, in theory, burn paper or take the moisture out of it and turn it into carbon. But as you can see by the colour, and there's small needle-like structures inside the solution, there's a lot of leftover copper sulphate that's been left over in the solution. So I could electrolyse that out, but I don't think it would be productive. Instead, we'll just leave it as it is, and yeah, that's it. In theory, that should be my sulphuric acid. And next I will try to make some nitric acid with this. It'll be very contaminated and dilute, but it'll still be nitric acid, and in the future I'll use the rest of the copper sulphate to hopefully make a bigger batch and get a lot more purer sulphuric acid, and maybe if I have enough we can try to distill some. Thank you.